Hello class, I hope you are doing well. Now today we continue with our trigonometry 1 topic. Today we want to deal with the trigonometric ratios of special angles. The special angles 30 degrees, 45 degrees, 60 degrees, 90 degrees. We are calling them special angles because we want to see how can we find a way, even without using mathematical tables, of getting maybe the tan, the sine, the cos of 30 degrees, 45 degrees, 60 degrees, and 90 degrees. You will be meeting questions that will require you not to use, without the use of mathematical tables maybe, and then you see such angles. Now, if we can start with, let's say, 60 degrees and 30 degrees. If you see such angles, consider an equilateral triangle. We want to consider an equilateral triangle of 2 units. So we have equilateral triangle then of 2 units, and you know an equilateral triangle, all the sides are equal. Then you have all these interior angles being 60 degrees. Now, we can drop a perpendicular bisector. Let's say we have ABC, triangle ABC. Perpendicular bisector will bisect this line AC into 2 equal. Remember, we have said we are using 2 units. So if we have this perpendicular bisector, we have 90 degrees here. So we have 1 unit there. We have 1 unit there. So we have our midpoint here. Now we can extract, then we have this as 30 degrees. The perpendicular bisector bisects angle B into 2 equal halves, bisects line AC into 2 equal halves. Now, if we can extract triangle, any of those triangles, we have M, let's say B, we have C, we have 2 units there, we have 1 unit here. By Pythagoras theorem, we can get the representation of this. So you take, so BM will be 2 squared minus 1 squared. You take the square root. This is 4 minus 1. So this one, the square root of 3, which we will call root 3. So this is represented by root 3. Remember, we have 30 degrees here. We have 60 degrees here. Now we can get the representation of maybe, let's say, sine 30 degrees. Sine 30 degrees. Remember sine from previous lesson. Sine. So we have our SOHCAHTOA there. Sine of 30 degrees, we are looking at the opposite, which is 1 over hypotenuse, which is 2. So the sine of 30 degrees will be represented by a half. Then we have cos 30 degrees. Cos 30 degrees adjacent, which is root 3 over hypotenuse, which is 2. Then we have tan 30 degrees. Tan 30 degrees, we have opposite, which is 1 over adjacent. Adjacent to the angle 30 degrees, we have root 3. So basically for 30 degrees, this is how we will represent. Even if you don't have mathematical tables, when you ask, this is how we will be replacing. Sine 30, a half, cos 30 degrees, root 3 over 2, tan 30 degrees, 1 over root 3. If we can look at 60 degrees, special angle 60 degrees, you're still making use of this triangle BMC. So sine 60 degrees. Now we are turning to this angle 60 degrees opposite, which is root 3, opposite over hypotenuse, which is root 2. We have cos 60 degrees, cos 60 degrees adjacent, which is 1, adjacent, then hypotenuse, which is 2. So cos 60 degrees a half, then tan 60 degrees, tan opposite, which is root 3, opposite over adjacent, which is 1. Now, interestingly, you can clearly remember the previous lessons when we were talking about complementary angles, sine and cosine. If you can see, sine 30 degrees, the complement of 30 degrees is 60 degrees. You can clearly see that sine 30 degrees is equals to cos 60 degrees. So basically, these are representation of special angles 60 degrees and 30 degrees, the trigonometric ratios. If we can look at special angle 45 degrees, consider an isosceles right angle triangle of base and height 1 unit each. So is an isosceles right angle triangle. So we have right angle triangle. We have 90 degrees here. It is of one unit. By Pythagoras theorem, clearly this is 1 squared plus 1 squared. You get this is root 2. So we can say maybe x, we call this XYZ, triangle XYZ. So we have 45, the base angles, 45 degrees each. So if we consider any of the 45 degrees, if we get sine 45 degrees opposite over hypotenuse, cos 45 degrees, we have adjacent over hypotenuse, then we have tan 45 degrees. Tan is opposite over adjacent, so this is 1. So basically, these are the trigonometric ratios of a special angle 45 degrees. So, if we can, an example, without use of mathematical tables and calculator, evaluate. We have cos 30 degrees sine 30 degrees over tan 30 degrees tan 30 degrees. Now, if you have been given such, your work is to just go back and see what is your cos 30 degrees. Cos 30 degrees you have, so you just make a replacement, root 3 over 2, root 3 over 2, then sine 30 degrees we have a half divided by tan 30 degrees, 1 over root 3 times 1 over root 3. So basically, we'll have this as root 3 over 2 divided by 1 over root 3 times root 3. And I want you to know, if let's say for example you have root a times root a, this one you will get a. Anytime you have this root a times root a, you have a. So basically this one will have 1 over 3. So we have, sorry, this is supposed to be root 3 over 4. So we have 3 over 4 divided by this. So we have root 3 over 4 times 3 over 1. Just leave your answer as this. Leave your answer in form of this sign. So this one will be the value of this. So anytime you have been given such, because they can even make a mixture of 30 degrees, 60 degrees, 45 degrees. Your work is just to replace. Remember the special angles, the trigonometric ratio. Just replace where you have been given. I want you to try out this. I want you to try out this. You have this, and you have 30 degrees there. You have 45. You have 45 degrees there. This is B, C, D. Then you have A. This is 10 centimeters. Then this is X centimeters. Find the value of X, leaving your answer in form of the root sign. So just a point of reminder, when you have been told without use of mathematical tables or calculator, and then you have been given these angles, please remember the trigonometric ratios that we have just derived. Thank you, and have a blessed time.